we're going to talk about collaborating between the Revit and the Plant 3D software. There's a lot of reasons why we do that. We're not going to get into that too much, but we did a presentation a few months back that talked about the different considerations that you have. In this demonstration or presentation, we're going to assume that we need to use both Plant 3D and Revit for the documentation, development of the project models because of features available in those softwares. So our agenda for today, we're going to take a look at design phases, and the reason we're going to look at design phases is, they can affect, or they should affect, how we do our collaboration, and I'll talk more about that later. Navisworks Manage is Autodesk's collaboration coordination tool, as you know. We're going to take a look at using that federated model, and we're also going to look at some newer capability dealing with the coordination models. On the Revit side, we're going to look at what we need to do to prepare the Revit model data for use in Plant 3D, and then also methods that we can use for referencing that data into Revit. But conversely, we're going to do the same thing from the plant side. We're going to look at preparing that plant data for use in Revit and referencing the Revit model data into your Plant 3D project. And there are going to be some different examples. Some of it is going to be based on the design phases, but some of it is also going to be based on somewhat your goal. Whenever you're looking at how you're going to approach something, you almost always need to start by looking at what your end goal is, because that is going to affect the decisions and the steps that you take to get from start to finish. So project design phases and how they impact collaboration. And this is, for all intents and purposes, my opinion. And you may have your own opinion, I'm sure we all do. But when we're talking about the design phases, schematic design in Revit is typically going to be something along the lines of doing some mass modeling. With the Plant 3D software, this is P&ID development. And this is an area that Plant 3D really has the advantage over Revit, because Revit doesn't have a P&ID modeling configuration or workflow setup in it. At the design development phase, we're talking about the model development of both the Revit project and the Plant 3D project. But at this phase, we're really looking at how we plan to fit or shoehorn the systems that we identified during that previous schematic phase into the space that we're allocated. This is probably the phase that demands the most amount of collaboration between the design team members. This is where a lot of the decisions are going to be made about how that project is going to end up looking or come about. When we get to the CD phase, we're talking about setting up heat views in Revit, and in Plant 3D, we're talking about creating orthographic drawings and projected views based on the model that we created. So at that point in time, we should pretty much be done with the decision-making process about the project, and that will change how we want to do our collaboration, so that we have the ability to do some things that some of the other options don't necessarily provide for us. And I've got fabrication shop drawings in here as well, because again, on the Plant 3D side, that's something that the software is designed to do. It has the ISO capabilities, very similar to the ISO Gen, which has been an industry standard for years. Excuse me, again, it's one of those functions that kind of differentiates Plant 3D from Revit when you're looking at whether or not one or the other is more appropriate for doing your documentation. And this isn't a definitive list, but just something to try and set a frame of reference for a discussion today. I also just want to take a quick look at the software, desktop and cloud-based applications from Autodesk that we'll be using. And we'll also take a look at how they impact the collaboration. On the desktop side, we're talking about your Navisworks Manage, your Revit software, Plant 3D. AutoCAD MEP is here because it's an intermediate tool for us, and you'll see how we deal with that later. Probably a little bit different than you think. And then obviously the Plant 3D Object Enabler. The Plant 3D Object Enabler is something that you need to make sure that you install after you have installed the other 4 software. If you don't install it after having installed Navisworks, the Navisworks presentation graphics for your plant models are not going to look as complete and definitive as you want them to. The Object Enabler does need to be installed after all of the software, and as we know, Navisworks typically needs to be installed after all of the design tools so that it installs its model exporting tools. Excuse me. We're not going to talk about cloud collaboration in the presentation today beyond just talking about what the tools are out there or the subscriptions are out there in terms of the Autodesk Construction Cloud, the current iteration of Autodesk Cloud Services, and then the BIM Collaboration Pro, which is the tool set that allows us to directly access our building model information with the design software. Excuse me. There's another intermediate piece of software that I didn't put on the screen here, and that's called the Autodesk Desktop Connector. And the Desktop Connector gives me the ability to basically tie the Windows operating system on my computer to the cloud-based Autodesk Docs project environment so that I can access information through the Windows File Explorer, and that will help to facilitate the sharing of data between my plant and my Revit projects that may exist up in the cloud for collaboration purposes. All right, so Autodesk Navisworks. Navisworks has been around for a long time. I'm using Manage as my example here. It could very well be Simulate for what we're talking about doing here. There's really no difference in that. We're talking about creating a federated NWF model. And if you know the Navisworks software, it basically allows me to take the various model project models that I have that are in different file formats and combine them by creating something called a cache file, an NWC file. That federated model then allows me to see in context each of the models so that I can do my coordination. This is where coordination started for Autodesk. There's different things that we can do now that we'll talk about, but this is the tried and true. If you need to, and I should probably advance here, if you need to be able to coordinate between models that have different file types, and in some cases you won't even have the software, you can actually append those model files into a Navisworks project model and be able to see that information, and it'll pull some intelligence in. It really kind of depends on the relationship between that model file type and the Navisworks software, but Navisworks actually opens quite a few different model formats, so you'll find that it is very just lost the word I was looking for, but it is a very robust tool for coordination. I mentioned the fact that there's some new capabilities or functionalities that have come from Navisworks for us, and this is more toward bringing the model information from those Navisworks models or the Navisworks cache files that we've created that represent models in different file formats than the design tool that you're working in. So I can link or reference a Navisworks cache file, the NWC files, into any of my Autodesk design software. This is something that has about 2 or 3 years or so, we saw it start getting introduced, and then I think it's now completely integrated into all the software. It's not a great presentation, but it is an ability to see, again, in context, inside of my modeling environment, the other model information without having to convert the data or having the overhead of that model's physical size impacting your workflow inside of your design tools, right? The NWC files that we link in, they're, again, very limited in terms of the visual fidelity, the capability of changing presentation graphics, and even the intelligence that you'll find that's part of that. The information that you would normally see from that NWC file inside of the Navisworks model does not follow through when we reference that into the design tools that we're working with. All right. So getting back to now the different development phases for your design projects. And I'm going to focus here really on design development phase and the construction document phase. And it may very well be that you need to use some of these techniques in some of the other phases as well, but I'd say it's a little less common. So when we're talking about working with the design development phase, where I'm trying to figure out everything that's going to go into that model and where it is, how I route to it, those types of things, whether or not I have collisions or clashes, that Navisworks NWF model or the federated model is really going to be the workhorse for that. And as a byproduct, the federated Navisworks model will also create the NWC files representing each of the individual design models that my team might be working with. Excuse me. So in the design development phase, I actually have both methods of using Navisworks listed here. So I could use the federated model directly, or I could link the NWC files into my model to make that work. And then when I just start talking about the construction documentation phase, I'm probably not going to want to use that Navisworks cache or Navisworks collaboration model. I'm probably going to want to go back to the full Navisworks federated model because of the ability to be able to pull dimensions and do markups and the visual fidelity and control and information that comes along in that file. Again, this is the way that I see things. Everybody's situation is a little bit different, but in this case, this would be my recommendation for using Navisworks in these two development or design phases. The imagery that I have here is meant to illustrate the relationship of your NWC files, the coordination model, as Autodesk is calling it, to the ability to see that information both in the Navisworks environment, as well as if you're using that NWC file as a link into your actual design software. As I change or step forward and step back here, you'll see an example of a pipe run that is visible in the first image and is not visible in the secondary image. And that's a result of a change to the design model, in this case, a Plant 3D piping run. And once that drawing was modified and saved, the NWC file was able to be refreshed to show those changes. And so the ability to have a reference file that is linked to the original model that can be simply refreshed is something that is very powerful in those early design stages to minimize the amount of administrative time it takes for you to exchange data. You know, at that point, we're not as worried about the pretty picture, but we're worried about being able to have the physical presence there so that we know that, you know, we can fit in a certain area, or, you know, where we might have conditions where we might end up having clashes or tight spaces. So if you've never done this before, by creating the federated model and referencing the actual design models, you can see in the image there, I've used 3 different drawing files from the plant model, and then I've used an architecture Revit model. And not really the correct model for this application, but it gives me the ability to show it. Inside of the selection tree, inside of your federated model. Now, it's not really showing me the DWG file, it is actually showing me an NWC version of it. It created a Navisworks cache file. It sits in the same directory as the model that it was generated from, and that's what gives me that ability to be able to refresh the information. If you're looking in your selection tree and you're seeing a NWC file extension on these as opposed to the actual file format of the design tools, that's not going to give you that same capability. Okay? So just something to be aware of. That transition didn't work the way I planned. So now I want to focus on getting the Revit data out to Plant 3D, and I'm using issuing and consuming as my my verbs here. But basically, the Autodesk Revit model format is the RVT file. The AutoCAD Plant 3D is still based on DWG, and the DWG format, or the Plant AutoCAD format, does not read or cannot read that Revit file natively. And so that does mean that we have to either use the federated Navisworks model that I talked about, or to use the Navisworks cache model linked in. The difference or the advantage of using the cache model is that you're going to not have to have 2 softwares running. If you're using the old school methodology, if you will, of having a federated Navisworks model of all the design models running in Navisworks, and then you're working on your design and then refreshing the changes that you make in your design tools, that's going to allow me to see things and to be able to coordinate fairly easily, but it's also going to be a little bit more overhead on the PC. It's, you know, going to change the workflow a little bit. So using the NWC file in this case, again, as I said, at the design development phase, I think it's a great time saver, and I know several clients that I've talked to that, you know, don't particularly care for it because it's very limited at this point in time. I can't snap dimensions, I can't snap the points, and you know, those things will get better as time goes on. But I think there is still a definite advantage because of the capability of refreshing directly from the source model as it changes. If I'm going to the construction document phase, then it's going to change my strategy a little bit, because the information that I'm seeing through the Navisworks file types is not something that I can use to create documentation inside of Plant 3D. I need to get information out of that Revit model in a format that Plant 3D will recognize. And by waiting to do it at the construction document phase, hopefully I'm doing it much less frequently or much less often than I would have to do it if I did it from the very beginning of the project. So we're talking about exporting Revit information, either model views or 2D views. I can export any of those as DWG files from the Revit software, and then I can use that information. If I want to use a 3D model in the plant environment to produce an orthographic drawing, you will have to copy those 3D drawing files into the plant project so that they are selectable when you're selecting the models to create your projections. So basically, I'm going to have my working version of my Revit model. I'm going to have some exported DWGs that I'm going to be using. If you simply export the Revit model and overwrite the original file in the project folder where it exists after it's already been added to the project, that should be all that you need to do. You won't need to add it back to the project every time. A simple overwrite of the base file in the plant project directory will allow me to update that information. On the 2D side, that's an area that unfortunately 2D detail or 2D information in drawings doesn't get projected by the orthographic tools in Plant 3D. So things like a floor plan maybe that shows my structural grids and my column locations combined with an orthographic projection of the equipment and pipe that I'm dealing with in the plant model. The views or the techniques that we see most commonly for this is to basically take that two-dimensional view, reference it into the Plant 3D orthographic drawing after it's been created and your views have been set up, and then layering those views on top of each other to create a composite or a see-through composite, if you will. There's obviously some challenges with that, or less than desirable results, if you will, of doing that. But one of the biggest challenges that we have with it is the file that we XREF in is going to have its own set of layers for visibility control, and then the views that we create from Plant 3D have a set of layers that are automatically created by Plant based on the view setup or the view direction, top view, front view, etc. If you layer a couple of views together and you change the reference layer structure and then refresh the view that you have from, refresh the projected orthographic view, I should say, the layers all get reset. And if I remember correctly, it's the entire drawing. So depending on how many references I've brought in, it could happen in a lot of different views. The way to work around that is to, when you XREF for that Revit 2D drawing into your plant environment or into your plant orthographic drawing, set up a view save or a layer save state in that drawing so that you can capture the layer state that that external reference should be. And then you can change the presentation graphics to match what you need it to be for presentation purposes. And then you can set a layer state for that as well. That allows me to switch from one to the other. And so that if I refresh one of the orthographic views, I can simply reset a layer state to reset the reference drawing that I'm showing underneath it to make sure that I don't have to spend a whole lot of time configuring the presentation graphics that I had for that view. Okay. So Revit into Plant, as I was saying earlier, and you'll see this as kind of a repeated theme throughout my presentation. At the design development phase, the easiest, best, fastest way to coordinate with a model that has a different file format is to try and use that Navisworks coordination model. Worst case scenario, as I said, we can have have Navisworks running in tandem with our design tools with that federated model open, and then as I make changes to the design, that federated model will also show me the changes. But again, that isn't going to be sufficient when it comes time to be able to create those projected views that incorporate both the 3D process information with the Revit structural or architectural information that you have in that model. Um, yeah, I got a little ahead of myself and I've already covered all of that. Okay. Now on the AutoCAD plant side, exporting my data, you'll see at different phases is not necessary. And then there are some different ways of doing it in the design development phase. So taking the Plant 3D model information out to a format that I can use in Revit. If we're talking about the design development phase, I can export to AutoCAD, and that creates a disconnected model file. It's going to be AutoCAD 3D solids. It's not going to have the intelligence the original model did. It's not going to update if the original plant model updates. It becomes a static base file that I would have to update periodically. But it gives me the ability to be able to see that information in context, and in the plant environment, I would be able to copy that drawing into the plant project and then be able to create projected views that includes the data from both models. Again, it doesn't allow some of the visual control and some of the things that we want there, so we can look at some other methods for that. And one of those other methods is to export my Revit model as an IFC file. If you're not familiar with IFC, it's the industry's data transfer standard for building model or object-based modeling technology. So you can take the object from one model format and convert it to something that another modeling tool will use to create a comparable object in its modeling format. Plant 3D unfortunately doesn't have the IFC import-export capability. And so that's why this gets a little bit different, because as you can see in my image here, or maybe not because it's kind of small, AutoCAD MEP comes into play here. AutoCAD MEP does support IFC import and export. And with the addition of the object enabler, the AutoCAD MEP software can open the native Plant 3D drawings. I don't have to export them first. And then once that drawing is open in AutoCAD MEP, I can export those to an IFC model. The IFC has several settings in it so that you can, make sure basically that pipe converts the pipe in, from plant to Revit and vice versa. But this allows me to create that IFC model, or that data transfer model, that allows me to bring information into the Revit environment and to create Revit geometry that basically matches the plant model. So it's not a live intelligent link, and it gives me the ability to present things. But again, if I'm doing this at a excuse me, if I'm doing this at a later stage in documentation, say construction documentation, hopefully I'm not going to have to do it multiple times, because if I have to do it multiple times, each time I'm working with the IFC, I have an option of either linking the IFC into my Revit models, or I can open the IFC, which creates a new one. And again, these two methods have some different functionality. The linked IFC model basically reads the IFC data and presents it in a Revit model so that you can see that information. It's fairly clear. And if we put that link inside of a in-place family, a modeled in-place component family inside of Revit, that data will respond to view range. I'm sorry. That's if you take the native plant drawing files. So over here in the diagram in the corner here, I'm saying if I take the plant 3D drawing files, I link those native files into Revit, because Revit will allow you to link in the native file format, or the DWG file format, if you will. Because of the fact that I can link that inside of an in-place family inside of the Revit model, that does give the Revit model the ability to present that data and to honor the view planes and display graphics of Revit at that point in time. So it gives me a quick and easy way to bring the plant information in at a design development phase without having to make any conversions or export to IFC, anything like that, and to be able to use it effectively in the Revit environment so that I can do my coordination and do my routing without having to spend a whole lot of time, again, converting model data. If, however, we go to construction documentation, then we have the two options. We can export, or we have an IFC file from our plant model that I can bring into the Revit environment or the Revit model, and I can do it in two ways. I can link it in, or I can open the IFC file up, creating another Revit model. The first example shows linking a Revit IFC file, or linking a plant IFC file into my Revit model, which creates a representation of all of that data in the IFC file. The disadvantage to that is I don't have access to select the objects individually and pull property data or metadata from it. I can't select a pipe and tell you what service it is or what specification it's using in this case, because I'm working with a linked model file. The advantage to this is that if that IFC file updates, the Revit model can update its view when you reopen the file. So it's going to look back to that IFC file the next time I open the project, and it's going to refresh the data that the IFC file is presenting to me in the link. The other method of opening the IFC model and actually creating Revit data from the content does give me some additional capability. The objects that I am seeing in the view in the middle of the screen here, these are not properly converted to the right object types, but you can see that it actually converted it to individual objects inside of the Revit environment that can contain all the same property information that came across from the plant models. There are always going to be some challenges with getting the correct data over, so you're probably not going to get everything, but it does a pretty good job of pulling that information in. This is probably one of the methodologies that I would use at that very last stage of design or of construction document development, because I don't want to have to do it multiple times, preferably. And by having a separate model here, now I have two Revit models that I've got linked together with that information in it. Or, I'm trying to get this model information into another Revit model, which is not an easy thing to do. I know I've talked to some clients that have some other workflows that have some similarities to this that they've used before. And there may be some advantages over some of the processes that they use over what I'm promoting here. My goal in presenting options here is to try and give you options that have the least amount of effort in terms of having to export data to be able to share between the two different platforms that you're working in, and to provide enough information at the different design phases to be able to use the data correctly for context. I went through that a lot faster than I expected. For the most part, I focused all on Autodesk software here. A lot of you will have the AEC collections, and everything that I've talked about here, except for the subscription applications, are part of that AEC collection. So you have the tools available. You can make use of them. In most cases, the biggest challenge is knowing how to make use of them. And hopefully this gives you some ideas on the different ways that you can share that data. It's always going to take some trial and error. You know, we're fond of saying trust but verify. I didn't use a whole lot of live demonstration in here just because of the fact that it seems like I can get different results in different circumstances. Just because I do something, make a minor selection change that's just minorly different in one run than it is in the other. And so I wanted to make sure that I was able to show the information a little more clearly. But third-party applications, if you are using them and like them, this will probably be an attractive feature for you. A lot of people are kind of leery about that. There's a large population of the AEC market out there that wants to be able to use a single tool to do the entire project. And in my opinion, that's not a really very reasonable request or desire. The softwares all have different strengths and weaknesses, and you need to use the right tool for the right job or the right application. And that's why talking about being able to coordinate or collaborate between a RVT Revit project file and a DWG-based Plant 3D model is, I think, so important, because there are going to be times where that's the best way to approach it. But being able to share the data between the different applications. So there's ways to do it inside of the Autodesk software that you already have, but there is some workflow to it. There is some effort that goes into that. There's a company out there with, and I think BIMDex is the actual name of the company, but they make several plugins for data exchange. They make a Revit to AutoCAD exporter, and then they also make a Plant 3D to Revit exporter. And if you read their literature, the Revit information that's exported to AutoCAD is not just 3D solid geometry as it is when we export to DWG from Revit natively. It's metadata rich content, and in a lot of cases it's blocks as opposed to just simple solid geometry. So it's going to bring more information across, and that's great because it can make different aspects of my job, depending on what my scope and my focus is, easier to work with. But again, it's not a dynamic or parametric link, right? If the original Revit model changes and I need to see that information in Plant 3D, I'm going to have to re-export it. I didn't see anything say that it had a relational export here. So my assumption is that it becomes a static data export when we do this. On the flip side, going from Plant 3D out to Revit, as opposed to creating just CAD blocks with solid geometry, it tells us that it will actually create Revit objects. So I'm assuming it's using some of the IFC technology in there somewhere, and transfers the metadata. And that metadata, when it transfers it, can be integrated into the family content that it creates automatically, or it can actually write a shared parameter file and then place all of those shared parameters in the content to track that metadata for you. So it sounds very promising. As with anything, you read the literature, then you test it out for yourself. And whenever we read something, we draw a conclusion. And that conclusion is not always the intent of the literature that we're working from. And in some cases, it's not as rosy as it appears to be. So I like to say buyer beware. There's a lot of tools out there, whether it's data export tools or content available for manufacturers. You have to vet everything. It's not something that you're going to find the silver bullet out there, if you will. There really isn't one. All right, like I said, I went through that pretty quickly, but thank you for attending today. I hope that I've given you some ideas. If you didn't already have a path, maybe I gave you some ideas to improve your process that you're already doing. I would also like to hear if you have a different process that you would share with the group, because we all do things differently. We all have different experiences, and those experiences allow us to be able to share information and know things that the rest of us